So when we talk about dispatch, so dispatch also known as GCD, Grand Central Dispatch. So what is the meaning of the dispatch? So dispatch execute code concurrently on multi-core hardware, macOS, iOS, watchOS, and tvOS by submitting work to dispatch queue managed by system. So it is the meaning of the dispatch because here we are executing code on multi-core hardware and dispatch queue managed by the system, not by the developer. So GCD is a low-level API for managing concurrent operations. So GCD will make your application smooth and more responsive, also help for improving application performance. So GCD will control which thread will execute which job will execute. So it decided by the GCD, not by the developer. GCD operate on a system level and is more knowledgeable about the system resources, how to best use them, how to arrange our activities for the best performance. So compared to developer, GCD is more knowledgeable about the system resources. So GCD is an API used to carry out the closure of worker pool. So it follow first in, first out order. So it offers developer an API that facilitates the scheduling of tasks. Which thread is used to execute a task is handled by GCD, not the developer. So execute them on appropriate dispatch queue. So actually GCD provides the facility for the developer of scheduling of tasks. So here no developer scheduling anything. GCD is providing the facility of scheduling of tasks. Which thread is used to execute is handled by GCD, not the developer. So it execute them in appropriate dispatch queue. So it is the main point here that thread pool is collection of threads which are ready to execute when needed and again stored in our pool after finishing executing. So here is a diagram of the thread pool. So here we are using task queue and here we are using thread pool and third is completed task. So after completion of the thread will be going into the completed task. So GCD adding all the threads, all the tasks into the task queue and thread pool is getting tasks from the task queue in, first out order and all threads are added in task queue in serial or concurrent manner. So all the tasks are coming into the thread pool in, first out order and in thread pool all the operations are performed and after performing the operation the thread is going into the completed task. If the task is again required, so the task will become into the task queue and it will again follow the first in first out order and will come into the thread pool and after completion of the thread pool it will come into the completed task. So here all the red symbols in the thread pool is showing that they are executing their job. Suppose one is available and after completion of their job it will come into the complete task. So the thread is performing like this into the thread pool. So next is what is queue? So the queue follow a rule called first in first out. So you can say that list of railway ticket booking or you can say gas booking, you can say a queue. So any line you can say queue. So one who come first in the queue will be the one who finish the checkout first. So it is the first in first out order. So next is what is dispatch queue. So it is the abstraction layer on top of the queue. So actually in concurrency the dispatch queue is also called a queue. It is the abstraction layer on top of the queue. So when we are talking about queue, so you can consider that we are talking about dispatch queue. So we can create queue easily using the dispatch queue class which is built on top of the Grand Central Dispatch queue. So because we are using here dispatch queue class which is built on top of the Grand Central Dispatch queue. GCD manage a collection of dispatch queue. They are usually referred as queue. So you can consider it as a queue. So the work submitted to this queue is executed on pool of threads. So all the work which is submitted into the task queue is executed in pool of threads. We have also seen in diagram. So all the tasks are executing into the pool of threads. So a dispatch queue manages the execution of tasks serially or concurrently on your application main thread or a background thread. So dispatch queue are FIFO queue. FIFO, you know that first in first out order queue, to which your application can submit task in form of block closer to object. So all the tasks we submit into the queue in the closure form, in the blocks form. An application can submit tasks to queue in the form of block either synchronously or asynchronously. So when an application submit the task into the queue, so it's used two methods here. One is the order of executing and second is the manner of executing. So the order of executing here decide that task will be picked up serially or concurrently. So it is the order of executing. How task will be picked up serially or concurrently. And the next is manner of executing. So it decides that how job will be executed synchronously or asynchronously. So it is the manner of executing that decide that how job will be executed in the pool of thread synchronously or asynchronously. So it's a very important point for understanding purpose. So here we use two type of dispatch queues. The first is serial queue and the second is concurrent queue. So these are the two type of dispatch queue we use into the GCD. We will compare here serial and concurrent queues. Serial queue pick one task at a time and concurrent multiple tasks at a time. So synchronous we will discuss in a minute. So synchronous function is one that execute all its work in a simple straight line or a single thread and control return from method immediately and start executing other tasks. So when we are performing single thread, so it's the serial, and when we are performing executing multiple tasks, so it's the concurrent. So the one who come first in the queue will be the one who finish the checkout first. So we know that in FIFO, who will come first in the queue will be the one who will finish the checkout first. So it is the FIFO. So serial follow the FIFO order, and in concurrent here is not sure who will finish the checkout first. So here we are not following the FIFO order. So here we are not sure who will finish the checkout first. Task will be added and finished serially in fixed order FIFO order. So you know that task here we are added and finished serially. So here is the FIFO order we are following. So they are added in a order. Task will always start in order they are added, but they can finish in different order. So it is the key point here. Task will always start in order they will edit, but they can finish in different order. So they can execute it in parallel means they can executing in concurrent manner. So in serial, task will execute one after the other. So in concurrent, all tasks execute at the same time. So you know that in serial, we are sure that first task will complete first, and in concurrent, not sure which task will complete first. So it's the concurrent where we are not sure which task will complete first. Serial queue are used to synchronize access to specific value or resources to prevent data races to occur. In a minute, we will discuss about synchronization, because in synchronization we perform one task after the another. So serial queue use the synchronized access and it prevent the data races, because here we are performing one operation, one thread at a time is executing. It prevent the data races or deadlock condition. So concurrent queues are often used to asynchronous access. In a minute we will discuss about synchronization and asynchronization. So concurrent queues follow asynchronization, because in asynchronization we can perform multiple jobs at the same time without waiting from other job. So one task will complete 100%, then another task will start. So in serial, you know that when one task will complete 100%, then the another task will start. So without completion of the one task, another task cannot be start in serial. So here one task does not have to wait for another task to complete. So in concurrent, tasks are not waiting for each other for completion. So it's the point of the serial, because it is slow, but here next task wait for the previous task completion, because here one task wait for another task for completion faster, because there are not waiting time and all tasks run at the same time. So serial queue and concurrent both queue affect the destination queue to which you are dispatching. So for better understanding of the serial queue, serial, you know that one task at a time, the one who come first in the queue will be the one who finish the checkout first. You know better that here is the diagram of the serial queue. So here task 1 come first in the queue and will be finish the checkout first, and here task C will finish the checkout in last. So it is a serial queue. So it will follow the first in first out order. So first task A check out first, and then task B will check out, then task 3 will check out. So it will follow the first in first out order. And in concurrent queue, you know that multiple tasks at a time. So we are performing here multitasking. So suppose here is the 3 jobs, task A, B and C. So they are starting at the same time, but they are not finishing at the same time. So it's the concurrent where we are performing multiple operations at the same time without waiting for each other. So the concurrent queue is not following the first in first out order. So next is the dispatching technique of the dispatch queue. It has also two dispatching techniques. It's also called the manner of the execution. So first is the sync, also called synchronous, and another is async, also called asynchronous. So we can use both async and sync in the code, but we use both in different. Sync and async affect the current thread from which you are dispatching. So here we will discuss about the difference between synchronous and asynchronous for better understanding of the synchronization and asynchronization. Synchronization, it will block the current queue until that task complete. So it will take only one task from the queue. It will block the current queue until that task will not complete. So another task cannot be executed until the current task will not complete. So it is the synchronization. And asynchronization, it will not block the current queue. So it will block the current queue and it will not block the current queue. It will initiate the task and move forward. The initiated task will execute in parallel. So in asynchronous means that it will not block the current queue. So it will initiate that task and move into the next task. Means that it will perform the multiple tasks at the same time. So it will not wait the completion of the another task. So synchronously starting a task will block the calling thread until the task is finished. So the meaning is same, that it will not execute the next task until the current task will not finish. So asynchronously starting a task will directly return on the calling thread where we are calling. So it will directly return on the calling thread without blocking. So it will not block the thread. It will return on the calling thread and call the another thread. So the meaning is same, that it will not block the current thread. It will move on to the next thread. So we are discussing that serial in we are performing one task at a time. So serial is following first in first out order, and in synchronization we are also performing one task at a time because it blocks the current thread and another thread will not execute until current thread will not complete. So the next question is that if serial is equivalent to synchronous. So the answer is no, because serial is a queue and synchronous is a way of executing the task. We are synchronous and asynchronous is the manner of execution we are using in thread tool. So it's not equivalent to serial because we can perform both synchronous and asynchronous in serial queue. It's not equivalent to each other. So it's not mandatory that we always use synchronous with serial. We can use serial with asynchronous as well. So next question is also related with the previous question, that is concurrent is equivalent to asynchronous. So here is the answer is same, that is answer is no, because concurrent here is the queue and asynchronous is the way of executing, how we are performing the operation on the queue. So it's the manner of execution we are performing on the queue in the pool of threads. So because we can perform both synchronous and asynchronous in concurrent queue also. So like in the serial queue, we are performing both operation synchronous and asynchronous. In the same way, we can perform both operation synchronous and asynchronous in concurrent queue. So it is not mandatory that we always use synchronous with concurrent, and we can use concurrent with asynchronous as well. In previous line we have also discussed the same point, that we use both synchronous and asynchronous in concurrent queue, so it's not mandatory for us that we always use synchronous with concurrent. So we can use concurrent with asynchronous as well. So it's very important for interview purposes as well. What is the difference between synchronous, asynchronous, and what is serial and concurrent queue? So all of these points are very important for interview purposes also. So we will also check in practical all of these points. So I am sure that if you have any doubts about these, so in practical all the doubts will be clear. So we'll start in practical. So let's start. So friend, for better understanding, we will implement how we use serial versus concurrent, and what is synchronization, what is asynchronization. So we will check here, and I'm sure that after completion of this demo you will be clear all these concepts. So first we will check how we use serial with sync. So sync means synchronization. So you know that in synchronization we perform all tasks one after the another. So it will block the execution until the current task will not be complete. So here we are using serial plus sync. So you know that it will maintain the order because it is serial. So in theoretical we have cleared that what is serial. Serial will follow the first in first out order. So it will maintain the order. So all the tasks are executed in order they are original added to the serial queue. So suppose here we are using dispatch queue. So I know that we have not discussed yet what is the dispatch queue, but I am expecting that you know about the dispatch queue. So here I am expecting that you know the basic of the dispatch queue, and in my next lecture we will discuss detail about how we use dispatch queue. So here I am using dispatch queue, and here is the label. You can use here any name. So I am using here serial queue. So I am not defining here any attribute, so it's expecting, and I am adding here also by default serial if concurrent is not defined. So I am not defining here concurrent, so it's serial queue. So suppose here I am performing multiple tasks in serial queue with synchronization. So suppose here is the thread 1, and I am performing here addition of two number. So it just a addition of two number I am performing here, and here printing the result, and after the result I am printing here task 1 is finished. And in the same way I am performing here second thread, and we are performing with synchronization. So I am using here sync. So suppose here just I am printing start 2 is started and task 2 is finished. So I am not adding here more code. So I am just printing here two lines started and finished. And in third thread I am adding and performing the addition of values of array. So I am taking here an array of the numbers, and I am performing the addition of the array, and just I am printing here sum of the array, and here I am starting the task 3, and here I am printing task 3 finished. So it's a work of all the threads. Now I am running this code and check what will be the output here. Yeah, so output you can check here that task 1 is started. So it means that first task 1 is started here, and then result of the task 1 is showing here. The result is showing here 15, and then task 1 is finished. So again the task 2 is started, and then task 2 is finished, and after finished of the task 2 the task 3 is started, and after this the sum of the task 3 array of the number is showing here, and then task 3 is finished. So you can check that all the operation is performing one after the another. So here task 2 is starting after finishing of the task 1, and here task 3 is starting after finishing of the task 2. So task is performing one after the another because we are using here serial queue. So we are using here dispatch queue as a serial queue, and we are using here synchronization. So in sync you know that it's block the current execution because we are performing the operation on the main thread, not on the background thread. So it's block the queue, and after finishing of the one task, it's performing another task, and it's following the order because it's a serial queue. So suppose now I am commenting this code, and now the second example is the serial plus async, and I am uncommenting this code, and we are using here same code. In the third, we are performing the addition on the array, and here task 2, task 1, we are adding the two elements. So it's the same operation we are applying here. So the change is just that we are using here async. In the previous example, I am taking sync, but I am taking here async. So all the threads I am using async. So I should be add here async. Yeah, so now I run this. So it will also maintain the order because it's a serial. So when we are performing any operation with a serial dispatch queue, so it will maintain the order. It can be synchronized sync or it can be async. So it will not matter it's a sync or async, but it will maintain the order because it's a serial. But it will not block the queue, but it will maintain the order because it's a async. So we are not performing the operation on the main thread, we are performing the operation on the background thread, but we are using the async with serial, so it will maintain the order. So now I am running this code. So friend, you can check that task 1 is started, then task 1 is finished, task 2 started, finished, and after this task 3 is started and finished. So the task 2 is not starting before finishing of the task 1, and task 3 is also not starting before finishing of the task 2. So it's also maintaining the order of the queue. So it's the second example. So suppose now I am commenting this code, and now I am uncommenting this code. It's the third example. So it's the example with concurrent and sync. So you know that in concurrent we can perform multiple operations at the same time. So but we are using concurrent with sync. So it will maintain the order. It will also maintain the order. We are performing multiple operation here, but we are using concurrent with sync. So you know that sync will block the current execution and next operation cannot perform until the current operation will not complete. So it will block the execution. So it's maintaining the order. So when we perform the operation with concurrent queue, so we should be add it here like that. Attribute is concurrent. So now the queue is considered as a concurrent queue. So we are performing the operation with sync. So we are using the same thread here also, and we are using the operation with sync. So now I am running the code and check what will be the output here. So friend, you can check that here task 1 is started and then task 1 is finished, task 2 is started, finished, and again task 3 is started and finished. So here queue is also maintaining the order, and here task 2 is not starting before finishing of task 1, and task 3 is not starting before finishing of task 2. So it's maintaining the order because we are performing with sync, and sync you know that perform the operation on the main thread, so the another task cannot execute until the current thread will not complete. So it's also maintaining the order. So now I am commenting this code also and check the another example. So the last is concurrent with async. So it's unordered. So it will not maintain the order because we are performing the operation with concurrent with async. So now I am uncommenting this code also and check what will be the output here. So here also we are using concurrent, so it's a concurrent queue, so we should be add here attribute as a concurrent, and the other code is same. like in previous examples we have used, but the basic difference is that we are using here async, and you know that in async we perform operation on the background, so we are not performing operation here on the main thread, so it will not block the current execution, so the other thread can be executed parallel. We will also use here async, and now I run this code. The other code is same we have used in previous examples. Yeah, so here friend, you can check that task 1 is started, and at the same time task 2 is started, and at the same time task 3 is started. So task 2 is not waiting for finishing of the task 1, and task 3 is also not waiting for finishing of the task 2. So all the tasks are started at the same time. So task 1 is started, and the sum is showing here. The sum of the 10 and 20 is showing here, and then the array element sum, and in task 2 I am performing also the sum of the two number. So in task 2 I am performing the addition of the two number. So some different in code is here because I am performing in task 2 the addition of the two number and performing the addition of the array element. So here task 2 we are performing the more operation compared to task 1 and task 3. So here 30 is showing. So here sum of the two number is showing here 30, and then someone is showing, someone is printing in task 2. So here 30 is showing in task 2, and the first is task 1 is finished. So task 1 is little code compared to thread 2 and thread 3. So the first of all task 1 is finishing here, and the sum is showing 150 of the task 3, and after this task 3 is finishing, and in last task 2 is finished. Because I have added here the more code compared to task 1 and task 3, so the task 2 is taking more time for finishing, and they are not waiting for the task 3 and task 1. So the task 2 is finishing at the last because it's not waiting for task 1 finishing. So all the tasks are not waiting for each other here, all threads are not waiting here each other, they are concurrently executing, they are parallel executing and performing the operation. They are starting at the same time, but they are finishing at different time. Suppose I am deleting this code from the task 2 now. So now the task 2 is very little code compared to task 3 and task 1. So I think now the task 2 will start at the same time, and task 2 will be finished before task 1 and task 3, because now the job of the task 2 is very easy compared to task 1 and task 3. So now I run this. So friend, you can check that task 1 is started, task 2 started, task 3 started. Task 1, 2 and 3 started at the same time, and first of all task 2 is finished because in task 2 I have added very little code, and code I have just added, task 2 is finished. So the task 2 is not performing any other operation, so very little code in task 2, so it's finished before task 1 and task 3. So now the sum of the task 1 is printing here, and then task 1 is finished. So the large code now the compared to task 1 and task 2 is in task 3, so it's taking more time and finishing at the last. So I hope it will be helpful for understanding what is serial, what is concurrent, synchronization, asynchronization. So friend, if you like this video, please like, share and subscribe the channel. Thanks for the watching.